All right, testing. Can anyone hear me? Is anyone listening? This doesn't really matter. I'm just gonna program this shit whether anyone's watching or not. So you could say I'm a little addicted. I'm a little addicted to TIS-100. I had to hold myself back from completing extra challenges because I thought I might want to stream this again. So here we are, but I couldn't resist doing a little bit of TIS. So let me show you what I did here. A little bit of show and tell. So I went back to the sequence reverser, and because let's just take a look at it here. We got these two stacks, and we're only using one here. We run it here, so you can see it fills the stack, and then it fills the stack from here, and then it poops it out in this direction, right? But if we were to use both stacks, we could be filling one while the other one was being outputted and back, vice versa, ping pong between them. So that's the idea of how you could, parallelize this whole operation. And I mentioned that yesterday, but I said, of course, no, we're not going to do that, especially not on stream. But after stream, I was like, okay, I'm gonna fucking do this. So take a look at this. This is the single stack version. 408 cycles to complete it. Hey, Tribane. Tribane's back. He's a big liar. He said he wasn't coming, but he couldn't stay away. No one can resist the charms of the TIS-100. So now here it is using dual stacks. So check this out. Now this one fills, and then when this one's filling, this one it's like a slinky. It's like a teeter-totter. One goes out, one goes in, one goes in, one goes out. It's a beautiful thing. It's also a fuck of a hell lot more complicated to do than the single-threaded version. This one took probably a couple of hours to debug because you need a lot of synchronization to make sure that you're not overwriting shit. But anyways, long story short, this one gets the job done in 286 cycles, which is, quite a good improvement over the single stack version. So I'm happy with myself. I just wanted to show that off. Now, let's get on to the next challenge. Oh, Tribane said that he couldn't help. Yeah, help. In quotation marks. You can't see, but I'm doing quotation marks beside my head here. I'm being a dick. Tribane did help yesterday, as much as I'm loath to believe this. But no, check this out. Before we move on, look at the cycle count thing. Look where we're at. Look at this graph. This is where most people are. The place where we're at, there isn't even enough people who achieved this to make it appear on the graph. I'm just saying. I'm just putting it out there that I might be a brain genius. But anyways, what I achieve off stream and what I achieve on stream are two very different things. Trust me. Just the psychological impact of knowing that there's an audience and having to talk to them while you're doing this shit, it fucks with your brain. People who have streamed a lot probably know that. But anyways, so signal multiplier. What are we doing today? I did peek at it. It's basically you take these two values in and you're going to multiply them together. Now here's the thing. If you watched the last stream, you probably know this thing don't have a multiply instruction. So we're going to have to do it by looping and adding to itself. Luckily, I'm an old hat at that implementation of multiplication. I've done it many times with many different things, including logic circuits. And I even implemented a program on the CPU that I built on stream. I wrote a program to do multiplication on that one. It also does repeat add. So we take one value in, that's going to be the count, the number of times we add this value to itself. It shouldn't be that hard. And after that, I might look at some optimizations because I know of a few already. But anyways, so move up into the accumulator is I suppose what we're going to want to do. Now, what we're going to do here is we're going to sub 1 from the accumulator, and then we're going to jump. If not, let me think here. So we should do the test first. Jump if not 0. No, jump if equal to 0 to end. Because there's a chance, like if you look at the input here, there are inputs that have, are there? Yeah, there's inputs that have 0, right? So that means that we have to add to itself 0 times. So we should test before we subtract. Good. All right, so then we subtract 1. Then I'm the guy who made the game engine. I don't know what that means. I don't know what it means. I'm going to say no in case you're like, I don't know, some angry person coming to extract revenge. But anyways, so after that, we want to move a signal to the right to tell the right one to do another addition to itself. So we're just going to move right, and I'll just call it 1 for now, but we'll get into what that signal has to be later on. After that, we just want to jump to looping, the loopy. So this is going to be the loopy. And then we have the end. This is what happens when we have counted down to 0. Well, we have to then tell the right hand side guy that we're done. So I'll just name that 2 for now, but it's going to be a different value. And then that's it, right? Because then we just go back up here and we move something back into the accumulator. So I think that is correct. For this one, again, we got to move up into the accumulator. Now here's where it gets tricky. So we're going to draw. We're going to draw. And what this one does, I actually did a little testing with this off screen. Oh, people are talking. Engine I did 2 years ago. Don't worry, Tribane. I already got it. You keep your ideas to yourself. You watch me and you learn from the master. Or alternatively, you tell me when I did something really dumb. But anyways, DirectX graphics thing. I mean, I made a framework. I wouldn't call it an engine. It's just a framework for learning shit. But I'm sort of making an engine right now. I'm in the process of making one, at least a rendering engine. I wouldn't call it a game engine yet. But that's neither here nor there. Today we're talking about the TIS-100. So the jump GRO actually does an line offset jump depending on what value you give it. So we can do a dynamic jump here. So we're going to let the value output from here control where we jump to directly instead of having to move it into the accumulator, which would overwrite our value and then having to compare. But anyways, so JRO left. So that moves the thing from the left and does the jump without having to overwrite our accumulator. All right. So now we have 2 options. One option is add. I should not put, because I don't know how GRO works with new lines. Like I know if you give it a 1, it will jump to the next line. But I don't know if you give it a 1, I guess it doesn't matter. But I don't know if it counts blank lines in that offset. I didn't do that much testing with it. So we're just going to keep everything on, we're not going to add any blank lines on this side. So the first one is add. Easy. Maybe not so easy. Maybe I need a little bit more here, because if I add the accumulator to itself n times, I'll actually be multiplying by a power of 2. Multiplying by 2 to the n, which is not what I want to do. So I don't want to add the accumulator to itself every time. I want to add the input value to the accumulator n times. So what I'm going to do, so we're going to move up right. We're going to use the right boy as a memory. Move left into the accumulator. Later, Zach, see you. Twin continuation is not an It's on the back burner. It's on the back burner. But so now my problem is I have to remember the initial value input from B because I need to add that n times to the accumulator. But if I move it into here, then I can move it. I can move ACK left, but I don't know how many times I have to move it left. That's a little tricky. The other thing I could do is I could back up into here, but the problem is if you back it up, there's no real easy way to add it. Well, you could, that's slow. That's very slow. You could swap and then put it out here and then swap and then bring it back. But having to do that for every iteration is very slow. Oh, man. The other thing is you could have a signaling. So this one would write a value to here, and then from that, this one would poop a value back. I think signaling is probably the fastest way to do it. I turned this one into a one memory cell RAM unit, basically, is what I'm doing right now. All right. So it's always going to want to move in a value at the beginning, so that's good. Now, the next thing we want to do is we're going to use JRO again. So JRO left, and that is going to tell us whether we want to do one of two things. We're either going to load, which will move ACK left, and then jump loop. You missed my amazing dual stack implementation of the sequence reverser AP. You missed it. Tribean, tell them how amazing it was. Yeah, so this one is if we're going to load. And otherwise, store. Store is just going to jump back up to the top, right? Because it's just going to load from here then. So this is what it looks like, I think. This is what our RAM, one cell RAM. Amazing. So what we're going to do now, so we move that right, we store it in our RAM, then we want to clear our accumulator. So move nil into the accumulator. Because, 0 times anything is 0, right? Tribean, that is slander. It's not slander, but it's something like slander. I'm pretty sure I could sue you for that. What I'm trying to say. I won't sue you because you give me money every month, so but I might be able to in some countries. Okay. Add. So if we're going to add, then we want to load from here and add that to the accumulator. So for adding, we want to move one right. And then we want to add right. And that'll add the thing that was moved from here to the accumulator. And then we want to jump loop. And the loop is right here. The loop is the place where we execute the command to move it in from here. Now the other thing that we want to do is output. So if we want to output, then we want to move, I'm thinking -1, right? That'll jump back up to here, get it ready to load a new value. And then we want to move ACK down. And then we want to move back up to here. These labels aren't actually necessary because JRO doesn't work on labels, it works on offsets. I'm just adding here for my own personal reference. Jerso, can I pick up assembly with this game? I mean, it depends on what you mean by pick up assembly. Are you talking about a specific dialect of assembly? Because obviously this is a fictitious machine. It's not going to teach you, a specific dialect of assembly. If you want to learn the basic skills that you need to write and debug assembly programs, this is not a bad way to do it. Although it's going to teach you a lot more stuff than you actually probably need, because the concerns that come in trying to work all the synchronization between cores when you get into the more optimized solutions, that's probably more thinking than you'll ever have to do with a normal assembly program. But, I don't know. Who cares? It's fun. That's why I'm doing it. Why you gotta make things so boring with like, is this the way I gotta do so I can grind my skills? I just do it because it's fucking sweet. So, anyways, JRO left. So if we are adding, we're going to jump with an offset of 1. But if we are ending, we want to jump with an offset of 2, 3, 4. What language is it? I think the thing about assembly, like people talk about assembly as if it's a language. There is no assembly language, right? Basically every machine has its own set of instructions, and generally the assembly mnemonics that we give to those is mainly based on the machine, but also on the assembler. There's no one standard assembly language. That's the first thing you got to know about assembly. All right, so we move this here, and after that, I think we're just good to go. We just loop up to the top, and I mean here we just got to move up, down. And in here, we just want to move up, down. So this... Well, I mean, we should probably do our syntax correctly. Move 1 to the right. Move 4 to the right. Right? 1 to the right, move -1 to the right. Yeah. So this seems like it could work. The thing about this game is your total scores for those 3 things, they count over all your programs. So typically, you write one program to maximize the cycle count, then you write another program to maximize the node count, and another to maximize the instruction count. And then your best scores of all those 3 give you your end result. Anyways, let's run. I might have just nailed it out of the park in the first try. Yeah. So I fucking killed it. As I will. Because I'm a brain genius. No one likes false modesty. I'm just saying it like it is. However. Also, I kind of want to try my hand at a little optimization here. But we're going to put it to the chat. Who says they want me to try to optimize this to improve its performance? Who wants me to move on to the next challenge? Well, I like democracy every now and then, if it suits me. So there's a few ways that you could optimize something like this. Let me just take a look at what the other tests datasets have in store for us before I decide on what I want to do. Tribean says optimize. Technophile says optimize. AP says me. Oh, optimize it, Daddy. I don't know what the other one was. I think he might have been having an aneurysm, but we won't hold it against him. It's probably the vodka, right? Okay, so all our inputs are all single-digit numbers. So this is going to inform, you know, what kind of optimizations will actually do anything for us. But the first optimization that I would look into is, you see that here, the amount of work we have to do is entirely dependent on the value that we get in A, right? Because A controls the loop, how many times we count down. Interesting thing about this is, for the end result, it doesn't matter which one is in A and which one is B. If you swap them, you still, I mean, 2 times 4 is the same as 4 times 2, right? So if you had, let's say, a 9 in here and a 1 in here, you would be 9 times faster if you were to swap them before you start your operation. So we want to sort our values before we start our multiplication. That's my thing. Now I'm realizing, as I say this, that oh, never mind. It's fine. Never mind. It was a brain fart. No, we're good. And it looks like we're going to optimize. But yeah, I looked at all these tests, random test, and yes, they're all single digits. So the other optimization you can make in this, by the way, is you decompose the numbers, the count number, into its powers of 2, and then you can do that thing where you add the value to itself a number of times, doubling it every time, and you can, you know, improve your performance by exponentially, I think. Yeah, I think that's how it works. But it would only be worth it for larger inputs. And also, I don't know if we could actually do it within the constraints of how many nodes we have. One thing I want to show you guys, I actually had 2 implementations of twin stacks. It's very interesting. So the first one here, it's almost the same as the other one, except that sometimes it works and sometimes it doesn't work. So in you get 3 tests and they're always the same value, but then you get a 4th test that's random values. So depending on what random sequences you get, sometimes it would pass and sometimes it would fail. Yeah, here it failed. But if I run it again, let me see if I can get it to go. Stop. Run. Nope, failed. Nope, failed. Nope, failed. Maybe I'm insane. Maybe actually it was a fever dream and it never passed once. But I'm pretty sure I could get this thing to pass if I just keep trying it. Yeah, there you go. So sometimes you can beat the game if you just cheese it hard enough. That's what I'm trying to say. And this is actually 3 cycles faster than my solution that works every time. So you see here, my total score for this challenge includes my best in each category. So I get 283, even though this solution fails like probably 4 times out of 5. It's random, but yeah. So, and to fix that, I had to add extra synchronization channels. It's very brain fucky to try to, because you've got to synchronize 4 different operations and make sure that they don't step on each other's toes. But the synchronization signals have to flow through this one thing here, and it's crazy. But enough of that. Let's optimize the signal multiplier. So I can copy this. No, I already copied it. So what we're going to do is we're going to bring the multiplication engine down here. Cheating, in this case, cheating did work a lot better. It took me maybe an hour to write the code that worked 20% of the time. And it was faster. It took an additional probably hour or more to get it to work all the time. So you save yourself time by cheating. You get a better score by cheating. There's really no downsides, is what I'm trying to say. The moral of the story is cheat whenever you can. All right, so here we're going to take our inputs like before, but up here we want to sort them. So this is interesting. So what I'm thinking we want to do is we want to use these guys as RAM, but this time I don't think we need signals because I think we know how many times we need to read from the RAM. So we can just hard code it. Move. So we want to move right into accumulator. And move left into the accumulator. So then we want to move up left and move up right. So first step, it doesn't matter. This is dumb. Move up in the accumulator. Move up in the accumulator. We want also a version, we want a value in the accumulator and in our RAM. Move ACK left. That's not how you spell that. Move ACK right. Okay, so now we got a copy in here and a copy in here. Next step. Now we want to move here to here and here to here. So now we want to swap them. So they both have access to both values. So that's a tricky part because you can't swap. You've got to do it. One has to do it first and then the other one has to do it afterwards. So, but if I move from here into the accumulator, I lose this one. No, it's not a big deal. All I got to do is move ACK right. That's not how you spell that. Move left ACK. Now I've lost the value in my ACK, but it's still in here. So I just got to do one move ACK left. And then I can move right left. And then move right ACK. So now we've swapped them. So this one contains A, B, A, B. Yeah? Yeah. So now they both have access to both values. And now we've just got to choose the correct value. So this one contains, I'm just trying to think here. So we want the lower value in here. That's important. That's a very important distinction. We want the smallest value in here. And we want the larger value in here. Yeah. So sub left. So we subtract A from B. So this is B minus A. Yeah? Yeah. So if the result of B minus A, this is where I usually write things on paper. But if the result of B minus A jump is less than 0, then that means that A was greater than B. And that means that we should choose B. Jump to less than 0, B. Otherwise, we should choose A. So to choose A is in here. Move left down. And then jump top. Get some, my phone is vibrating. Right. Now, if we're choosing B, then we want to move left nil. We still have to consume one from left because either way it's going to output for us. So we need to make sure we consume it so that the left side doesn't lock up. And then fuck. So before I do this, we've got to save B. So move right into accumulator, save. Then in B, we want to swap move ACK down, and then move left and nil to consume, and let this guy go back to the top and do his freaking job. So that's how this stuff has to go down, I think. I don't know, my brain hurts. Let's do it for the right side now. It's mostly the same thing, but it's not exactly symmetrical. Maybe it's not the same. It's probably symmetrical. Sub right. So this one is going to be B minus A. B minus A. This one's, no. Fuck. This one's B minus A. This one, we have A in here, minus B. Yeah, that's right. A minus B is the opposite. Part of me just wants to just choose one, just go jump less than 0 and then just run it and see if it works. And if not, just change some of the values. Sometimes that's an actual legit strategy. My main problem with that is that that's how some people just go through all their programming. So they just don't really think things through at all and just try things that they think might somehow be the right thing. And then when it doesn't work, they come to me and I'm I ask them questions why did you think this would work? I don't know. I just typed it out. Anyways, that's neither here nor there. I'm not calling anyone out in particular, by the way. In case you feel called out, it's probably not you. Just a general thing that I somehow notice. So back to the problem at hand. A minus B. Now we want to find the biggest one. So if A minus B is less than 0, then that means that B is larger. So this should still be B, which scares me a little bit. It's not law. There's a little bit of that, but it's not a lot. Generally, she has an idea. She doesn't just randomly try things. Now, I'm talking about people who often just come. It's mostly troubleshooting stories from the beginner series. People who are new to programming and are new to, I don't want to say new to thinking, because that's a very dickish way of putting it, but I'm not saying it. Anyways, programming teaches you to think. Let's just be positive here. Move. No. So if it's for B, B is here, right? So if it's A is in here. So we should swap. Move ACK down, move top. That's not jump top. And in here, we have the top. Okay. Next one. If we're choosing B, move right down. Yeah. And that's it, right? Yeah. So move ACK left. The first one here is for the swap. The second one is for the sub. And we got to do one for the sub here. Move ACK right. The third one is for the actual output. Move ACK left. There. This should be enough. So yeah, it's not symmetrical, but it makes sense because the swap is not symmetrical. This swap overwrites ACK, so we got to use the one from here and pass it through to here. All right. It's not going to work, is it? Yeah, it blocked. First two answers were correct, though, which is nice, I guess. Move ACK right. Yeah. I gotta do something for a second. I will be right back. I'm right back. I didn't mute myself there. Good thing I didn't say anything derogatory under my breath, because that would be embarrassing. Anyways, so why are we blocking up? Why are we getting constipated here? Well, let's just step through it. Nothing like stepping through your code. So move up into accumulator. 1 and 8. Beautiful. Move accumulator left and right. Yeah, we got our 1. We got our 8 there. Move accumulator right. Move left into accumulator. So that should copy the 1 into here. So far, so good. Then move accumulator left. Move right left. That goes into here. So now we have our 1 and our 8, or 1 and our 8. 1 in here. No, wait, that's the different one. But you get the idea. The 1 is also in here, and the 8 is also in here. Good. So far, so good. Now we save. Good. Now we subtract left and subtract right. 7 and negative 7. So jump if less than 0 to B. Not less than 0. So we're going to move this one, we're going to move the left one down, which is correct. That's the smallest one. So far the logic is good. Jump if less than 0, B. Move the right one down. That's also correct. So our logic is correct. Yeah. Was I just missing a jump or something? No, because I got a jump top there. Move up into accumulator. Jump top. Yeah. Move accumulator right. Move accumulator left. Yeah. Something's fucky. No, wait. 4, 1. That's correct. 4, 1. Save. Yeah. Sub. Good. So far, so good, right? People keep messaging me and I don't like it. Can you guys hear that? Can you hear that noise, that message notification noise? 1 second. What's up with people trying to get me to do my job? I just want to stream TIS-100. What's wrong with that? I don't know, man. Crazy. Anyways, back to debugging. Okay. Now I lost my freaking place. Frustration. Move accumulator down. Yeah. Good. So what's the freaking problem? Why are you being a dick? Oh, 0. Okay, so maybe getting a 0 in one of these causes my shit to fuck up. Fuck the shit up. Move. So 0 and 4. We got a 0 and you got a 4 in here. Move accumulator right. Wait. This didn't get consumed. So one of our branches here isn't consuming. Okay, that's good. Jump with less is your V. Swap. Move accumulator down. There it is. There's the constipation. It was right here the whole freaking time. Freaking Tri-Brain. I told you, if I do something dumb, you gotta point it out. It's making... God damn it. You give this guy one job. One freaking job. I'm about to lose my freaking mind here. Anyways. Move. Nil. No, wait. Move. Right. Nil. It's okay, Bane. It's okay. We're cool. Your job is to be the scapegoat. So when something goes wrong, I have to have someone to blame other than myself. So you're doing your job perfectly fine. Just keep doing exactly what you're doing. All right. Good. This should work. Let's try it. All right. I think we're good. Stop. Fast. Okay, so this is faster because before we were here, now we're here. But apparently you can get way faster. I have an idea of how you could get way faster. So remember when you said, when I said you could decompose into powers of 2? And you could do that programmatically, but because we only have a very small range of inputs from 0 to 9, it would be possible to do it with a lookup table, the decomposition, using the JRO instruction, I think. So, what I'm trying to say is that I have an idea of how you might be able to do that, although I'm not sure. But I'm definitely not going to do that fucking shit on stream. No goddamn way. Anyways, so we got... Fuck. This is a slow one, right? Yeah, this is a slow one. 1432. And we managed to bring that down to 1038, which isn't a bad speed up. Not bad at all. Maybe close to 33%, 30%, somewhere around there. It's good. And it's as good as we're going to do today because I want to move on. Chili wants to explore new frontiers. Oh, it's beautiful. So, image test pattern. So here, I showed this, I think, yesterday. We saw it in the manual. But there's also an image output peripheral. So we can output, instead of outputting just numbers, we can actually output, we can plot onto a small image here. So, seems like fun. But let's check the manual, first of all. I've not done any of this before. But I have seen it in the manual. So, TIS-100 contains a visualization module that allows programs to programmatically create and display images. The module contents can be modified by sending command sequences. So we got to send sequences here, which makes sense. We've only got one port, which consists of starting X coordinate, the starting Y coordinate, one or more color values, and a terminating negative value. The coordinate system starts at 0, 0, located in the top left of the display area. So yeah, top left, 0, 0. Now I don't understand this termination thing. So let's look into it a little bit more. So I got some colors, good. 30 by 18. Draw a horizontal red line in top left corner. So we get 0, 0, 4, 4, 4, 4, 4. So the 4 here, the final 4 is red. What are these fucking other 4s? I don't fucking get it. Sorry. Excuse my language. I'm just... Which consists of starting x coordinate, the starting y coordinate, one or more color values. I don't get it. Okay, we're just going to test some shit. It's time to test our shit. Move. Let's try this out here. Move 4 down. Move 4 down. Move 4 down. Move 4 down. Wait. Yeah. That's better, right? Move 4 down. Move -1 down. Okay, so this is the example that they show in the manual. If we run it, okay, stop. So 0, 0, 0, 0. Then we move a 4. That gives it 1. So it has a cursor that moves left to right. Is what I imagine is going on here. So you can draw horizontal lines quite easily or quite efficiently by just sending multiple colors in there. But vertical lines, probably not going to be that great, is it? So, okay. But we understand how it works at least. Now the program, it just wants us to fill the screen with white. That can't be too hard, can it? What happens if... I'm just wondering, like, this horizontal cursor that automatically advances, does it also wrap? Easy enough to test, right? Move 0 down. Move 0 down. Move... What's red? White is 3. Jump infinity. Okay. So let's see what happens when we do this. Okay, it doesn't work. All right. Fine, fair enough. Fair enough. So we just need to count. And then go to a new line. How wide is this boy? 30 characters wide. So we just got to count down from 30. And then every 30, we want to do our thing. We can do this all in one. I think we could do this all in one unit, right? Move 30 into the accumulator. Then but okay. So we need a counter for the Y. And that'll be in this guy here. So we'll do it in two units. So sub 1. No, add 1. Move, act right. So this will be our boy, that gives us y coordinates. And when we start a new line, we're going to move 30 into the accumulator. We're going to move 0 down. We're going to move left down to get our starting coordinate. And then we're going to move 3. Yeah. Down. Sub 1. Jump greater than 0. Loop. X loop. So this is the X loop. Now, if we reach the end of the line, we've got to output the terminator. Blah! That's my terminator impression. And then, yeah, we just jump back to the top. Do it all over again. Okay. Little wrong. Probably want to add one after. Might as well do that now. Let's go. That looks good to me. Pause it. Fast forward. Yeah, okay. Wow. So there's someone who could do it maybe quite a bit faster? I suppose if you unroll the loop, let's see, it's 30 characters wide. So move 3 down, move 3 down. Move 3 down. That's 1, 2, 3, 4, 5, 6. And we can subtract 6. That's probably the biggest thing that divides into 30 that we can get away with. What was our speed before? Let me just check this out here. Leave. So we had, where is it? Here it is. 2282. One 382. There you go. Loop unrolling for the win. There you go. You get that one for free. Should have give you that one for free. All right, return to the segment list. How long have I been streaming for? What? Where's my thing? Oh, here we go. About an hour. All right. Well, I think that's good enough for today. I didn't want to stream too much. Just wanted to do a little bit. And it was a great success. Thanks all for coming in. And now I'm going to go play some Slay the Spire. See you guys later.